Have you ever wondered why lobsters turn red when you cook them? I mean, they're like this bluish-gray color when they're alive, and then when you cook them, they turn bright red. Is it because they're angry? Well, no, not exactly. It's actually because of their shell. See, lobsters have shells, and their shells are made of chitin, which is also what insect shells are made of. Chitin is a natural polymer, meaning it's made of lots of small molecules called monomers that are linked together in a long chain. In the case of chitin, the monomers are linked together through a really strong chemical bond called an ether linkage. These ether linkages give the shell its rigidity and help it maintain its shape. But there's also another part of the shell that we're going to talk about today, and that's the pigment. The bluish-gray color that lobsters have when they're alive comes from a pigment called astaxanth. Astaxanthin is a carotenoid, which is the group of pigments that gives many animals their colors, including flamingos, salmon, krill, and even some birds. Carotenoids are really diverse, and there are tons of different colors in this group, including yellow, orange, and red. But astaxanthin is one of the only bluish pigments in this whole group. And that's because astaxanthin has a really unique molecular structure. Basically, it has these long hydrocarbon tails and 5 rings, 4 of which contain oxygen. And all of these parts interact with light in a particular way that gives it that bluish color. Now, astaxanthin occurs naturally in lots of organisms, but it doesn't always look bluish. For example, in krill, astaxanthin doesn't have those long hydrocarbon tails, and so it looks more like a red pigment instead. So the reason that lobsters are bluish when they re-alive is because of both the chitin in their shell and the structure of the astaxanthin molecules. And cooking lobsters causes those ether linkages in the chitin to break down, which makes the shell softer. But it also causes the astaxanthin molecules to lose their bluish color. Now, you might be wondering, if the lobster's shell is turning red when you cook it, why does the meat turn white? After all, isn't the meat just another part of the shell? Oh yeah, the meat is part of the shell. It's technically called the exoskeleton. But the meat, or the soft parts of the lobster, contain much less astaxanthin than the shell does. So when you cook the lobster, most of the astaxanthin in the meat stays intact and just turns a lighter color, whereas the astaxanthin in the shell breaks down into a reddish-colored compound. Cooking it also causes the proteins in the meat to denature or unravel, which makes the meat look white instead of having that bluish color. Basically, the reason that lobster meat looks white is because it was never very pigmented to begin with. Now, you can actually buy frozen lobsters that are already cooked, and they're usually a bright red color, but that's because they were dyed with a red food coloring called erythrocene 637. This stuff is actually banned in the European Union because it has the potential to cause thyroid problems. But it's still approved by the FDA for use in seafood here in the US, and it's often used to dye the insides of these cooked lobsters bright red to make them look more appetizing. So the next time you're eating a lobster, remember, that bluish-gray color that you see is due to a really unique pigment called astaxanthin. And the reason that it looks bluish in lobsters is because of the way that its molecules interact with light and the structure of their shell. Cooking breaks down those structures, which allows the light to interact with the astaxanthin molecules in a different way, making them appear red instead. Speaking of things that appear one color but are really another, have you seen our video on clear slime? It's a fun way to learn about polymers and how light interacts with matter. Check it out at the website below. And thank you for watching this Sea Show video.